Hello everyone. In this video I will be explaining the second method of line balancing, that is largest candidate rule method. So in the earlier video I have explained method 1 of line balancing. So any method of line balancing involves three different steps. Step 1 is to decide what is the cycle time. Step 2 is to draw the precedence diagram for the given work elements. Step 3 is to balance the line, that is all the given work elements have to be distributed or allocated to different workstations such that our idle time will get reduced. So here in case of largest candidate rule method also, these three steps are generally involved. So for which I have taken the same example problem which we have discussed in the earlier video. So the question is, the precedence relationship of an assembly line is as follows. The desired output capacity is 48 number per day. If the factory runs 2 shifts per day, each shift of 8 hours duration. That means a particular factory complete output is 48 number in a particular day. So a day comprises of 2 shifts and each shift comprises of 8 hours. That means in the duration of 16 hours they are going to make 48 number of products. So as I said, there are three different steps here. Step 1 is to decide what is the cycle time. Step 2 is to draw the precedence diagram, and step 3 is to balance the line. So here there are 7 different work elements, and for completion of 7 work elements they have given the time duration in minutes. Also the precedence values are also given to us. As I said, to draw the precedence diagram we have to keep in mind that all the 7 elements are interrelated or interconnected with each other in a logical sequence. That means all the 7 work elements, that is right from 1 to 7, they have to be connected in such a way that these precedence condition have to be satisfied. That means here we see work element 1. To start work element 1 there is no precedence given here. That means work element 1 need not wait for any other element because it is given as dash or nil. It represents dash or it represents nil. That means work element 1 need not wait for any other element. Okay. Similarly work element 2, it has to wait until work element 1 is finished. Here work element 3, 4, 5, they have to wait until the second elements get completed. That means after completion of second element only the work element 3, 4, 5 will get start. That means these 3, 4, 5 they are interconnected with the second element. Similarly sixth element is interconnected with the 3, 4, 5. Until unless these 3 elements gets completed the sixth element won't start. Similarly seventh element will start only after completion of 6. That means all the different work elements given in the problem, they are interrelated or interconnected with each other in a logical sequence. So once again I explain, to draw the precedence diagram you have to understand what do you mean by a node. A node is nothing but it is a circle where you are going to put the activities or the elements into it. That means all the work elements 1 to 7 you are going to put it in the circle where each circle represents a node, and these arrow marks or the lines with arrows represents a logical sequence. So here if we see work element will start without any disturbance because the precedence is not given to us. Okay, so before it there is no precedence for work element 1, it can start individually, right? Similarly to start with work element 2, 1 has to finish. Since we have completed with 1, you can start with 2, that is 2 will start only after completion of 1. So therefore 1 to 2, clear, 1 to 2. Next 3, 4, 5 they are interconnected with the second element. That means these 3, 4, 5 will start after completion of the second element only. That means 2 to 3, 2 to 4, 2 to 5. That is what I have done. 2 to 3, 4 and 2 to 5. 3, 4, 5 are interconnected with or interrelated with the second element. Clear. Next 6 is interconnected with the 3, 4, 5. That means 3 to 6, 4 to 6 and 5 to 6. So 3, 4, 5 already we have completed with. Now these 3, 4, 5 are connected to the sixth element here. 3, 4, 5 they are connected to 6. And finally 6th is connected to 7. That means 7th will start only after completion of the 6th element. In this way you have to draw the precedence diagram. That is step 1. After completion of step 1, then you need to decide what is the cycle time. So formula for cycle time is available time per day divided by required output per day. What is available time? As I said, a factory runs for two shifts and each shift comprises of 8 hours. 2 into 8, 16 hours. You have to convert that in terms of minutes because the values are given in terms of minutes. You need to convert hours, 16 hours into minutes. That means to multiply, to convert it into minutes, you have to multiply it with 60. 2 into 8, 16, 16 into 60 upon what is the required output in a day, they are going to get 48 number. So therefore the value which you are going to get as cycle time is 20 minutes. Okay, so this is step 2. After completion of step 2, then step 3 is to rearrange the duration time, whatever the time values which are given in the problem. So the work element, duration and immediate precedence I have given, I've taken as usually. That means work elements 1 to 7, and next the precedence values are given as is. The same values here I copied, and the time duration, the same values here I have copied, right? After completion of this, then you need to arrange these work elements in the descending order. That means in a decreasing order. Starts with the highest elements, ends with the least element. That is, highest element is 10, next highest element is 9, next highest element is 8. Here you can see 2 times, you can write it in any order, 8 and 8. Next highest element is 6 and next highest element is 5, which is repeated 2 times here, and their corresponding work elements are represented here. Say for example 10, what is the work element here? It is 1, so 1 is represented corresponding to it. Next next highest element is what is the next time duration? 9 is the next time duration with work element 6. Work element is 6 with the duration of 9 minutes. What is the next time duration, highest time duration? 8. So as there are two 8s here, you can write it in any order. So I will write it in a sequential order, 5 and 7. So 5 and 7. 8 is repeated 2 times, 5 and 7. Next highest element is 6, 6 for 2. Here you can see 6 for 2, and 5 is repeated 2 times, which is for 3 and 4, which is for 3 and 4. So this is a way only which is followed for the largest candidate rule method. Whatever the durations which are given in the problem, they have to be rearranged in the decreasing order. Starts from the highest element to the lowest element. Okay, after completion of this, then you need to distribute the various work elements into different workstations. So here to distribute the work elements into workstations, as I said in the last problem, there are 2 conditions to be remembered. So any work element, before assigning it, you have to check for the precedence elements. That is, all the precedence elements must be allocated. That is condition number 1. Condition number 2 is the time must be available. So whatever the durations which you are giving to the assigned elements, that should not cross more than the cycle time. Let us try to understand these 2 conditions. Both the conditions have to satisfy. Let us understand these 2 conditions by seeing at the problem. So here let us take with workstation 1 first. So here I have written eligible elements as well as assignable elements. Though how many number of as many as number of elements can be eligible, but only few elements can be assigned based upon the conditions that we have seen here. So let us see eligible elements. I will start from the beginning and I'll end with the last one. So first element is 1 here. So I'll start with 1. You have to check for the precedence elements. So here the work element 1 and the precedence is nothing. That is, work element 1 need not wait for any other element. So it is eligible for station 1. So therefore 1 is eligible, and the same 1 is assigned here with a duration of 10 minutes. Okay. Next I will come with the second one. Since 1 is completed, now I can strike it off. For our convenience, you have to strike off the elements that you have assigned. Okay, so once you have completed with work element 1, then I will go with 6. To start with 6, you have to complete with 3, 4, 5. The precedence values have to be satisfied, right? According to condition 1, the precedence elements must be allocated. So the second element is 6 here. To start with 6, you have to allocate 3, 4, 5. Since we have allocated only 1 till now, we have not allocated with 3, 4, 5. 6 is not given priority here. Similarly, the third one is 5. To start with 5, the second element must be allocated. Since we have not allocated with the second element, only 1 is completed. Therefore, 5 is also not given priority. Okay, next the element is 7. To start with 7, 6 must be allocated. 6 is also not allocated till now. Therefore, 7 is not given priority. Next element is 2. Here you can see, to start with 2, the precedence value is 1. That means 1 must be completed to start 2. Right? Since we have allocated 1 already here, right? 2 is coming into picture. That is eligible elements. Right? 2 will come into eligible elements. The same 2 I will assign here. Okay. So what is the value of duration here? 6 minutes. So for 1 it is 10. For 2 it is 6 minutes. 10 plus 6, 16 minutes. What is the cycle time which we have calculated? It is 20 minutes. Since it is not exceeding, since 4 minutes is still available, now let us verify for some more elements that can be assigned here or not. Since we have completed with 2, I will mark it out here. 2 is allocated. Now let us check for 3. To start with 3, 2 must be completed. Since we have allocated 2, therefore 3 is coming to eligible elements. So if I assign 3 here, what happens? What is the duration you have here? 5 minutes. Since 10 plus 6, 16, if you add 5, it becomes 21. So what is the cycle time? We have 20 minutes only. Since it is exceeding the cycle time 20 minutes, therefore it is eligible for station 1, but it cannot be assigned as it is exceeding the cycle time. That is, it is not satisfying the second condition. So therefore 3 is eligible, but it cannot be assigned. Okay, next element is 4. To start with 4, even second element must be completed. Since we have completed, even 4 is also coming into picture. What is the duration you have? 5. So even if I assign 5 here, so same 10 plus 6, 16 plus 5, it is becoming 21. So therefore 4 is also eligible, but according to the time, you cannot satisfy with the condition. Therefore 4 cannot be assigned. So after completion of 4, once again you can come back from the top. Since 1 is allocated, now you check for 6. To complete 6, 3, 4, 5, we have not assigned. To start with 5, next 5, the precedence is 2. Since we have completed with 2, so therefore 5 is also eligible here. What is the duration? It is 8 minutes. So if I assign 5 here, what happens? 10 plus 6, 16 plus 8, it becomes 24. Even it is exceeding the cycle time. Okay, though 3, 4, 5, they are eligible into workstation 1. 3, 4, 5, after completion of second, they will start. Since we have allocated with second, but they cannot assign into workstation 1 as it is exceeding the second condition. That is, cycle time is exceeding. Clear? Next. That is 16 minutes we have completed. Therefore 20 minus 16 becomes 4 minutes. Now we enter into second station. So here I have started with station 2. Now let us see from once again. Let us see from the top once again. So here I will start with 6. To start with 6, 3, 4, 5 must be completed, but we have assigned only with 1, 2. 3, 4, 5 is not assigned. Therefore 6 will not come into picture. Now 5. Let us see for 5. So to start with 5, second element must be completed. Since we have already completed with second element, therefore 5 is coming into picture here. Okay, into station 2. The same 5 I will assign here with a value of how much it is? 8 minutes. So the same 8 minutes I have copied. Okay, since I have assigned for 5 minutes, so I will strike it off 5 here. 5 is assigned. After completion of 5, then we come for 7 in an order. So to complete with 7, to start with 7, you have to complete with 6. Since we have not allocated 6, therefore 7 is not given priority. 2 is already allocated. Next, to start with 3, okay, the second element must be completed. So therefore second element already we have completed. So here 3 is given priority. So the same 3 I will enter here to the assignable elements with the value of how much? 5 minutes. Okay, so here it is 5 minutes. Since we have completed with the third element, so I will make a tick mark here and I will mark it off, station 2. Okay, next we come for 4. To start with 4, the second element must be completed. Since we have allocated second element to workstation 1, therefore 4 is also eligible now. What is the time duration for 4? It is 5 minutes. So the same 5 minutes I have copied here. So if you calculate the time, 5 plus 5, 10 plus 8, it is 18 minutes. So it is not exceeding the cycle time 20 minutes. Still we are left with 2 more minutes because cycle time is 20 minutes. We are left with 2 more minutes. Let us verify for any other elements that come into station 2. Since we have allocated with 4 also, I will strike it off 4. So now leftover are 6 and 7. Let us see, to complete with 6, to start with 6, 3, 4, 5 must be allocated. Okay, 3, 4, 5 we have already allocated. So 6 is also eligible, but if you add the duration, what is the duration here? 9 minutes. Okay, so what is the value here? You have 18 is already completed. So 18 plus 9 will become 27 minutes. It is exceeding. Therefore, I cannot give priority for 6 here. Okay, so only this is eligible for this particular station 2. Okay, now coming to station 3, only 2 are left over, 6 and 7. Let us come with an order. To complete with 6, 3, 4, 5 must be allocated. 3, 4, 5 anyway we have allocated. 6 is eligible. The same 6 can be assigned here into assignable tasks with a duration of 9 minutes. So duration is 9 minutes given here. So therefore 6 I will make a tick mark and I will make a round off. Okay, and the last one is 7. To start with 7, 6 must be allocated. Since we have allocated 6, now 7 is eligible. The same 7 I will assign here into the assignable task. So therefore the duration is 8 minutes. 9 plus 8 becomes 17 minutes. So what is the idle time now? 20 minus 17 is 3, and here 20 minus 18 is 2, and 20 minus 16 is 4. 4 plus 2, 6, 6 plus 3 is 9 minutes. What is the idle time we have? Total idle time is 9 minutes. So in this way you have to assign different elements given in the problem into different workstations such that our idle time must be reduced, but only the point is you need to keep 2 points in mind. The conditions, the 2 conditions. Condition number 1 is all the precedence values must be allocated. The second one is you should have enough available time that should not cross the cycle time which you have calculated. So this is the way where you solve the line balancing problem for the second method, that is largest candidate rule. Thank you so much for watching the video.